Hello everyone, welcome to pythonvibes YouTube channel. Today we are diving into a classic problem that's a favorite among coding interviews and competitive programming challenges, the two-sum problem. Imagine you are given an array of integers and a target sum. Your task is to find a pair of numbers within that array that adds up to the given target. It might sound simple, but this problem often tests your algorithmic thinking and problem solving skills. In this video, we are going to break down the problem step by step, also explore different approaches to solve it, and analyze their time and space complexities. By the end of this tutorial, you will have a clear understanding of the two-sum problem, its various solutions like brute force, hash maps, and more. But wait, before we dive in, make sure to hit that subscribe button and ring the notification bell so you never miss out on our programming tutorials. And if you find this video helpful, don't forget to give it a thumbs up and share it with your fellow coders. Let me open IDE and start writing the code. I had defined one method named two-sum problem and I'll be passing list and the target number. We will look at the brute force method initially and later we will enhance this code. So let me take an empty list called results. Next I will loop over the elements in this list. Later I will find the complement and then I will check if this complement present in the list or not. If it is existed, then I will append the tuple of complement and the element inside this results. At the end I will return the results list. Let me save it and run it. So this has all the duplicated elements as well, like 1, 8 and 8, 1. So these two pairs will add up to 9. That's okay, but seems to be we have duplicate tuples. To avoid this sort of duplicate pairs, we can write one condition. If this tuple combination is already existed in the results, then we will not going to do anything. And whenever it is not existed, then only we will append the tuple combination inside this results list. And then finally return the results. If we look at the time complexity of this code, for looping over all the elements in the list, it will take order of n. And to check whether this complement is in the list or not, it also takes order of n. And also we are checking whether this combination pair like complement and the element tuple is present in results list or not. That is also going to take order of m. Overall, the worst case time complexity of the code is order of n square, where n is the number of elements in the list. This is because in the worst case, for each element, the code has to check all other elements in the list to find the complement. Let's try to enhance this code. I'll be taking one dictionary called cindict and which will hold the numbers which I have in this list and its corresponding indexes. So what I will do, I'll take this cindict here and later I will take the index and element by using the enumerate. I'll take for element and index is in enumerate of list values. I will check whether this complement is in cindict or not. Then I just have to append results.append of complement comma element, and also I had to store elements and its corresponding indexes. Let me save and run it. So we have 4, 5, 3, 6. So this is how we got the results. So in earlier case also we got the same result. Let me explain what is happening here. So initially I had taken one list with all these numbers and I have passed my target 9. And next I have initialized two variables, one as list and other one as dictionary. And this list is going to contain all the pairs of tuples. And this cindict will hold the elements and the corresponding index. I'll be looping over the index and elements inside this list. So for the first iteration, the index would be 0 and the element equals to 1. And it will find the complement here. This equals to 9 minus element is 1. So this finds the complement as 8 and it will check whether this 8 is in the cindict dictionary or not. So this cindict is empty initially. So this 8 is not available. And it comes to the 8th line and it will store that element with the index as a value. So for the first loop, cindict will hold element is 1 colon 0 as its value. And next for the second loop, index will become 1 and the element value will be 2. And it will find the complement like 9 minus 2 equals to 7 and it checks whether this 7 is in dictionary or not. So in the cindict we have only 1. 7 is not available in the cindict. So it will add that second element also into the cindict with 2 as a key and index would be 1. And next, and for the fifth iteration, it will have element as 5 and index as 4. And now it finds the complement as 9 minus 5 equals to 4, and this time 4 is inside the C indict. Now it will add the tuple into the results list, like element is 5, comma, complement is 4. After adding this pair into the results list, it comes to next line and it will add that 5 with its corresponding index, which was 4. Next iteration, it would be 8 and index would be 7, and it checks the complement 9 minus 8 equals to 1, and this complement 1 is in C indict. Yes, it comes to the if block and adds that complement and element tuple inside this results list, like 8 comma 1, and in the next line 8 would be added as a element with the index 8 colon 7. So this is how at the end we will return this list, results list. So we will have this as our results. So let me save it and run this. So we have 5463 7281. Now if we look at the time complexity of this code, so to loop over all the elements in this list, it takes order of n. So overall, in the worst case scenario, the time complexity of this whole code is going to be order of n.
That's all, guys. Thanks for watching this video. Please do like, share and subscribe to pythonvibes YouTube channel. Your one like will help me a lot. Till the next video, happy coding.